topic is cathodic protection of steel in concrete. This is one of the protection techniques. Before I go further, I'll give a very brief introduction about myself. I have a PhD in concrete durability, and I have 30 plus years of experience in the Middle East. And most of my experience is in the Middle East. And recently I moved to India, and I established, along with my partner, Mr. Salim, sitting over here, one company called Structural Integrity Engineering. And services we are going to provide, we are intended to provide is assessment, repair, cathodic protection, and durability studies. While people were talking, my predecessor speakers were talking, they were talking about the historical buildings, why they are durable, and why the present structures are not durable. I did not prepare, just now I prepared it. Historical buildings, the durability reason behind that is they use the right people. They were built by kings, so kings have put the proper people. Nowadays, if you go to any structure, any building, like around 5-story building, or I'm not talking about 25, 30-story building, go to any 5-story building, 4-6-story building, and try to look for a civil engineer. You will not find a civil engineer. So what do you expect from that one? This is general, but technically they did not use reinforcement in the olden structures. They were lime mortars, they were stone masonry. So reinforcement is the problem. Now coming to the why reinforcement corrodes, I'll go very quickly over this. Reinforced concrete is a durable material. Otherwise, if there is no chloride or there is no carbonation due to its high alkalinity, the alkalinity breaks down. You can see in the picture on the right side, because of chlorides entering into the concrete are present from the beginning, or carbonation, carbon dioxide entering from environment into the concrete. Then what happens is corrosion propagates, and the corrosion products build up, causing cracking. Now when steel corrodes in concrete, in soil or water, what happens is anodes and cathodes are formed. This minus 500 is a cathode, minus 600 as an example is an anode. So anode is corroding with respect to cathode. So in cathodic protection, what we do, how do we protect concrete structures against reinforcement corrosion? First thing is good quality concrete, which is low water cement ratio, use of supplementary cementing materials, good curing, a larger cover to the reinforcement, and good quality control practices. In addition to that one, if your structure is exposed to aggressive environment, you need additional protection. These are not given in the codes but as a requirement, but it is given as a recommendation. So it can be additional protection, can be a surface coating. It has a limitation. Every technique has a limitation. It has 10 to 12 years of life. Fusion bonded epoxy coating rebars. It has a very big challenge. Avoiding damage to coating is a very big challenge. To my knowledge, I have not seen any coated steel used without damage. They repair the damage, of course, but the quality of damage will not be as good as fusion bonding. Then stainless steel is coming up. Again, this is for critical structures exposed to harsh environment. And there is another one mostly used for industrial structures, which is cathodic protection. It's a proven technology. It has got, it can be designed for service life of 40 years. And it can be used, the beauty of the technique is, it can be used even if the concrete is contaminated with excessive chloride. So you are seeing on the top, anodes and cathodes are formed. As you apply the cathodic protection, you go down, and you will see all the sides have become cathode. That's, you are making all the anodes to cathode. And once you reach the negative potential, 850 in soil, for steel in soil, you get the cathodic protection. So we are applying current, external source or through a sacrificial anode to make the anodes cathode. Beneficial effects of cathodic protection in concrete is hydroxyl ions are collected near the steel, which increases the alkalinity, and chloride ions, because they are negative, they are driven away from the steel, and that's why steel will get more passivity, and because of that, with time, the current demands reduces. Common candidate structures, you cannot apply for any structure. Common candidates are foundations of critical structures exposed to chloride contamination in soil, more than 0.5% or more than 1%. Bridge foundations, these are all exposed to harsh climates, not like one in Hyderabad, like coastal areas or industrial areas. Marine structures, seawater intake and discharge structures in industries, and concrete pipeline. if they are buried. This is one type sacrificial anode. You have this is the structure, and this is the anode. What you do in this one is just connect the structure with the anode. Here it is shown that it is connected in the test station. So the sacrificial anode will sacrifice itself and protects the steel. And this is impressed current iron anode system, where you use an external power source, and you have the anodes. You supply external current through anode, through power supply, and it protects the structure. It can be applied to steel structures buried in soil or water, or reinforcement in concrete. There are different types of sacrificial anodes. The most commonly used is the zinc anodes, and the advantages are easy to install, cost effective, less cost, and there is no need for maintenance, just install and forget. But there are limitations because of they provide limited current due to small limited anode material available, and therefore it's applicable to smaller structures. Like this is the anode which is commonly used, commercially available, and commercially available in different weights, 40 gram to 330 grams. So design life is claimed to be around 20 years based on the current density of 0.4 to 1.6. So the operating current density for cathodic protection is somewhere between 1 and 2 milliampere per square meter. So I just calculated based on 1 milliampere per square meter, which is an average operating current. 40 grams will give you around 3.5 years. 160 grams, there are varying weights are available. 160 grams will give around 13 years. And if you use the highest weight, which is 330 grams, it will give you 28 years. So it has to be designed. It cannot be just used blindly, because the data sheet says 20 years. I will use just 40 gram and I will expect 20 years. Another type is zinc anode, zinc jacket. This is used for piles. I will not go into the details. You can see in the picture how it is applied. And then zinc mesh anode, it is applied to the soffit of the slab or top of the slab, depending on which side of which top reinforcement is corroding or bottom reinforcement is corroding. This is zinc mesh. Material is zinc, but different shapes are there. Zinc sheets are there. Again, these are applied to the slabs or horizontal surfaces. And then thermally sprayed galvanic anodes are also available. You thermally spray the zinc on the concrete surface. And impressed current anode, this is used mostly in industries and more commonly used than sacrificial anode. And it is used for large structures, and it has got longer life expectancy. You can design the life actually. Concrete with any chloride level can be protected using impressed current as well as sacrificial. It meets varying current demand. If your current demand increases, like you want to connect more structures to your system, you can increase the number of anodes and you can increase the current capacity. Disadvantage is a high cost because it's a high-ended material and regular maintenance is required. So these are different types of anodes. You can read the paper. I will go to the conclusions. This is how to install. You can see in the paper, and how you do the maintenance and all. So as a conclusion, design of durable concrete structures in harsh exposure conditions is a two-step process. One, good quality control, quality concrete, no compromise for that one. Like low water cement ratio, use of supplementary cementing materials, larger cover, good curing, and good construction practice. And then additional protection. You need additional protection. And additional protection can be surface coating, can be epoxy coated rebars, can be stainless steel, can be cathodic protection. Thank you for your